Assalamu alaikum. Yes, children. In the last video that you must have seen, we started third exercise and solved question number 1 of that exercise. This exercise has a total of 5 questions, so 4 more questions are there. You get your things ready, your copy, your pencil, your pen, keep things ready. We'll try to solve these 4 questions today of this exercise. Let us begin with question number 2. Diagram of this question is not drawn on the textbook. You have to use the statement to draw the diagram. According to the statement, we have AD is an altitude of an isosceles triangle, ABC, in which AB is equal to AC. You are given an isosceles triangle. You draw an isosceles triangle. A triangle with 2 equal sides is called an isosceles triangle. The names of the equal sides are given, AB and AC. Let us mark both those sides by 2 short lines showing those are equal. AB is equal to AC. AD is an altitude. Altitude is perpendicular. Perpendicular from the vertex to the opposite side. This is the altitude. AD is the name. Perpendicular, so angle of 90 here. AD is an altitude of an isosceles triangle AD in which AB is equal to AC. We have to show 2 results. 2 results we have to prove. First, AD bisects BC. BC is divided into 2 parts here. BD and CD we have to show these are equal. AD bisects BC. And second, AD bisects angle A. Angle at vertex A. BAC is divided into 2 parts by AD. We have to show those also are equal. AD bisects BC in the first part, AD bisects angle A in the second part. We have to prove. Well, as usual, we'll first write what is given to us, what is to be proved, and then we'll write the proof. Given and to prove, as usual, you'll get from the statement, from the start of the statement up to the word show, you have given. So write that given there. AD is an altitude of an isosceles triangle, ABC, in which AB is equal to AC. Then you have to prove 2 results. First part, AD bisects BC, and second part, AD bisects angle A. To prove these parts, here we have the proof. We find by drawing this AD, the original triangle ABC is divided into 2 smaller triangles. One on the left side, another on the right side. Let us draw those roughly here. Rough column you make the 2 triangles. First one is ABD. This is the one. ABD triangle. It has right angle at D. Another triangle is ACD. This is the one. ACD triangle. Right angle at D again. Now these 2 triangles we would like to prove are congruent. For that you need 3 pairs of elements from the 2 triangles, which you will have reasons that those are equal. Well, you know here AB is equal to AC, it is given to us. This is the first pair we will use. We also have an angle of 90 degree in both the triangles. And then common side of the 2 triangles also we have. AD is the common side. AD is the side of this triangle as well as this side, this triangle. These will make the 3 pairs of elements therefore. And when we identify them, we have a right angle, we have a hypotenuse and one of the sides. Therefore, For the congruency of these two triangles, we shall be using RHS congruency rule. Right angle, hypotenuse and side. There are two sides and one angle. We cannot use here SAS congruency rule. According to SAS congruency rule, the angle must be the included angle of the two sides which you have reasons from one triangle and another triangle are equal. We use the side AB and AD from the first triangle. And if you are asked to name the included angle of these, that is at vertex A. AB and AD have A as the common endpoint. Therefore, the included angle of these two sides is at vertex A, which we do not know here is equal to the corresponding angle. Instead, we have angle at vertex D equal to angle at vertex D, which is a right angle. Therefore, SAS rule will not be applied. On the other hand, we have the rule called RHS, which fulfills the conditions here. So we'll use that rule. Let us prove the congruency in triangle ABD and triangle ACD. We have. So we are using RHS congruency rule. We'll first write right angle. Angle ADB is equal to angle ADC. What will be the reason you will put? Each 90 degrees. Both these angles are 90. Right angle, hypotenuse. So next after right angle, we'll use hypotenuse. We have AB equal to AC. It is given to us. Right angle hypotenuse followed by side, and side here is the common side. AD is equal to AD. This is the common side. Therefore, we can conclude the two triangles are congruent. Triangle ABD is congruent to triangle ACD. We have used RHS congruency rule. Now, having proved these two triangles congruent, we'll use CPCT. And you will have three results of CPCT as discussed earlier. We have so far used two sides. Now one more side is left. From this triangle it is BD side which is left. From this triangle it is CD side which is left. So therefore according to CPCT we'll have BD equal to CD. Right? Therefore BD is equal to CD. CPCT. Which will mean that AD bisects BC, because BD equal to CD. Two parts of BC therefore are equal. Means BC is bisected. So we can write therefore AD bisects BC. That was the first part of the proof. Now also according to CPCT, you can have two more results according to CPCT. Sides we have used, all the three. Two were given to us, known to us. Third we used as CPCT. Now out of the angles we have used so far, angle ADB equal to angle ADC, each 90. Now two more angles are left in both the triangles. Out of these you have to find out which are the corresponding angles, and then those will be equal. Angle at vertex B in this triangle will be equal to angle at vertex C. These are corresponding angles. Angle B equal to angle C. And the third angle at vertex A in both the cases, angle BAD is equal to angle CAD according to CPCT. This we need. Angle BAD is equal to angle CAD. This is another CPCT result. Third CPCT result, that is angle B equal to angle C, can also be written, but that is not helpful to us. We don't need that, so we'll not write. Angle BAD we proved now equal to angle CAD according to CPCT. These are the two parts of the whole angle BAC. Angle BAD and angle CAD in the actual figure make the whole angle BAC. And this whole angle BAC is divided into these two smaller angles which we have proved equal by AD. So what will we conclude therefore? AD bisects angle BAC. Therefore AD bisects angle BAC. It is this angle BAC which has been given the short name in the statement as angle A. So the final result is AD bisects angle A. That proves the second part of this question. This was your second question. Now what to third question. Diagram of question number 3 you have on the textbook. You draw that. Figure 6.40. You have to draw this according to the statement in this figure. There are two triangles ABC. This is the first triangle. Triangle number 1. And triangle PQR. This is the second triangle PQR. This triangle is triangle ABC. This triangle is triangle PQR. Two triangles are there. Now in these two triangles, median is drawn. AM is the median in the first triangle. PN is the median in the second triangle. By median you have read, we mean median. You can note down the definition of median somewhere on your copy. It is the line segment joining vertex to midpoint of opposite side. Midpoint of opposite side in the triangle. That is called as median. Midpoint of opposite side. Vertex is joined to the midpoint of opposite side. The name of the median in the first triangle is AD. Out of the alphabets A and D which are involved, A is the vertex. So therefore it will join A, the vertex, to the midpoint of opposite side. Opposite side is BC. D will be the midpoint of the opposite side. BC, you have to mark the midpoint of BC as D. Then join A to D. AD will be the median. In the second figure, PM is the median. It will involve the vertex P and the midpoint M of the opposite side QR. The line segment joining them is the median. PM is also the median. So therefore we know that this BD is equal to CD because D is the midpoint. We also know QM is equal to RM because M is the midpoint. Now the statement says two sides AB and BC. BC is the whole side from B point to C point, side of the whole triangle ABC. AB side and BC side and the median AM. Sorry, it is AM here, not AD. It is AM here. And in the second figure, it is PN, not PM. Side AB, side BC, and the median AM of first triangle are equal to the sides PQ, QR, and the median PN of the second triangle. So we have AB equal to PQ. Side AB of first triangle equal to side PQ of second triangle. The whole side BC of this first triangle equal to the whole side QR of the second triangle. Now, whole side is being equal, that will mean in turn their halves also will be equal. We have two halves of both of these, BC, QR. Two halves here are BM and CM. Two halves here are QN and NR. Therefore, these two and these two, all the four parts will then become equal because the whole length BC is equal to QR. And then we also have the median AM of this triangle equal to the median PN of this triangle. Median is also are equal. Then we have to prove those two results. Triangle ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. You complete this diagram and then start writing given and to prove from the statement. Consider the textbook, write given and to prove from there. Well, like all other parts, given will start from the start of the statement, word to, two sides. From there you have to start given up to the triangle PQR, Pn of triangle PQR. Up to that you have to write the given. After given, you write to prove. Two parts are there. Triangle ABM is congruent to triangle PQN. This is the first part. Triangle ABC is congruent to triangle PQR. That is the second part. And let us now try to prove these one by one. Proof. To prove this, I would like to keep one result ready. I just now said, since this BC is equal to QR, it is given to us. Therefore, the halves of these also will be equal. We have two halves of BC, we have two halves of QR. Those halves also will be ready, will be equal. And this result we have to use later. So therefore, let us keep this ready. BC is equal to QR. It is given to us. So write in the bracket given. So what will we therefore have? Their halves also will be equal. Half BC will be equal to half QR. And two line segments are equal, their halves also are equal. Now their halves being equal, we have two halves of BC. M is the midpoint. Why we say M is the midpoint? Because it is given that AM is the median. Median definition you have seen. It is the line segment joining vertex to the midpoint of opposite side. So there is midpoint involved. M is the midpoint therefore. BM is equal to CM. These are two halves of BC. We have two halves of QR also. QN and NR. Therefore these halves will be equal. Means all these four parts will be equal. BM, MC, QN and NR. All these will be equal. We need this as we prove the congruency of the two parts. So having proved this, let us now prove part number 1. In part number 1, we have to prove triangle ABM. This is the triangle. I will tick mark in that. Left side smaller triangle. Here triangle PQN. This is the one. These two triangles we have to prove congruent. And now for congruency, for proving them congruency, we have sufficient reasons. We have elements of this triangle equal to elements of this triangle. We have AB equal to PQ. This is given to us. One side. We have AM equal to PN. That is the second side of these two triangles. This triangle second side, this triangle second side. It is also given to us. And the third one we have just now got here. We have BM equal to QN. This is BM, this is QN. These are also equal. Thus by SSS congruency rule, the two triangles will be congruent. So let us prove in triangle ABM and triangle PQN. We have AB equal to PQ. Put the reason given. Then AM is equal to PN. Again put the reason. It is again given. Third, BM equal to QN. The reason is, we will write this time, proved. We have proved this result. Just now we proved here. BM is equal to QN. So we have 3 points. With these, we can conclude the two triangles are congruent, and that will prove our first part. So write therefore, triangle ABM is congruent to triangle PQN. We have used SSS congruency rule. That completes first part. Now from this congruency rule, from this congruency of the triangles, by CPCT we'll have 3 results. All angles of this triangle equal to angles of that triangle, corresponding angles. Out of those three CPCT results, we need only one for the second part. That is this angle B and angle Q. These are corresponding angles, will be equal. Therefore, angle B is equal to angle Q. The reason is CPCT. We need this in the next part. Though, two more pairs of angles can also be written are equal. Angle at vertex A, angle at vertex B will be equal. Which angle at vertex A? There are many. The one which is in this triangle, I have tick marked here, angle BAM. Here it is angle QPM. These two angles will be equal. And in the second, for the third angle, you have to use angle at vertex M, angle at vertex N, angle AMB equal to angle PNQ. These also will be equal. But we don't require those later in this proof. So therefore, no need of writing. This completes our first part, and the CPCT result that we wrote here will be used in the second part. Let us begin now proof of second part. We have to prove again congruency, but this time congruency of the original triangles, whole triangle ABC, whole triangle PQR. Now you have to prove congruent. Consider these. We have. I will roughly draw these two triangles here. This is the first one, ABC triangle. This is the second one, PQR triangle. To prove their congruency, let us find out which elements of first triangle are equal to the corresponding elements of second triangle, and you must have reasons for that. We have sufficient reasons. We have AB equal to PQ, that was given to us. So first point. We also have this BC side. 4 short lines I will put, because 2 I have put here, 3 I have put here. So 4 I have put. Equal to QR, this also is given to us. BC equal to QR. It is given to us. And then their included angles, angle B and angle Q, we have just now proved. That CPCT result is the included angle. Two sides and their included angle of one triangle equal to corresponding sides and included angle of another triangle. And that will help us to conclude that the two triangles are congruent. The congruency rule is SAS. So we have AB is equal to PQ. You'll write given as reason. Then angle B is equal to angle Q. We have proved it. We also have BC equal to QR given. With this, we'll conclude the two triangles are congruent. Triangle ABC is congruent to triangle PQR, and the rule used is SSS congruency rule. That completes the proof of this question. The next, question number 4. Question 4. Diagram of question number 4 is not drawn there. You have to draw again this diagram using the statement. We have BE and CF are two equal altitudes of a triangle ABC. There is only one triangle, triangle ABC. A triangle ABC. In this triangle, according to the statement, we have two altitudes. Just now in question number 2 also we discussed altitude perpendicular from the vertex to the opposite side. BE is the altitude, therefore it will be drawn from the vertex B to the opposite side. BE is the altitude, perpendicular. This is BE. Angle here is 90 degree. We call such perpendicular as altitude. BE is one altitude. CF is another altitude drawn from vertex C to the opposite side. Angle here is 90 CF. And it is given that these altitudes are equal. BE is equal to CF. It is given to us. Using RHS congruency rule. congruency rule also is given here. You have to use that congruency rule. You cannot use now the congruency rule of your own choice, because the name of the congruency rule is given there. You have to use that rule itself. Rhs congruency rule. Prove that the triangle ABC is isosceles. You have to prove this is isosceles triangle. Two sides are equal. Well, as usual, write from the statement what is given to us. Hurry up. From the statement you can see, begin from the start of the statement. BE and CF are two equal altitudes of a triangle ABC. This is given. After that, what you have there, that is to be proved. You have to write to prove triangle ABC is isosceles by using Rhs congruency rule. You will add the words there. Triangle ABC is isosceles by using Rhs congruency rule. Let us prove this. So we write proof. To prove the result, let us consider triangles. Many triangles are formed in the figure. You can identify. Out of those triangles, you have to choose two triangles. And then we'll prove those two triangles congruent. And for the congruency, remember you have to use Rhs congruency rule. The two triangles which will help us, I shall draw roughly here. One will be this triangle. BCF, it has right angle here. And another will be the similar one, triangle BCE, this one. This is right angle at E. Both these triangles have one side common, that is BC. And this common side BC here in both the triangles is the side opposite to right angle. Therefore is the hypotenuse. So we have right angle and hypotenuse, right angle and hypotenuse. Rhs congruency rule besides right angle and hypotenuse involve one side also. RHS, right angle hypotenuse side. Now you have to use one side also out of the remaining two sides, BF and CF in the first triangle, BE and CE in the second triangle. We must have one of the sides of this triangle equal to the corresponding side of this triangle. That is given to you. BE is equal to CF. Thus we have right angle, hypotenuse and one side of one triangle equal to right angle, hypotenuse and side of another triangle. That will help us to prove the two triangles congruent by Rhs congruency rule, as asked in the question. There is another pair of triangles also involved in this. That can also help us to prove the congruency of these two triangles. Look at the triangle ABE. This one. And the corresponding triangle ACF. Right angle at F. Using this pair of triangles also we can prove the result. But here the congruency cannot be proved by using Rhs rule. What do we have this time? BE we know is equal to CF. We have angle of 90 degree also. The third element in this case will be the common angle A. Thus, this time we have two angles and one side of one triangle equal to two angles and one side of another triangle. Triangles are congruent, but the rule is not Rhs rule. Therefore, this pair of triangles will not be used. Had those words not been there by using Rhs congruency rule, then you could use this pair of triangles also. Now those words, therefore, mean that these two triangles we will not use. You have to use these two triangles. So consider in triangle BCF and triangle BCE. We have congruency will be proved by Rhs Congruence Rule. Right angle BFC is equal to angle BEC. Reason is each 90 degrees. RHS has first R word, right angle I have written first, followed by H, hypotenuse, and the hypotenuse here is the common side. BC is equal to BC, common side. It is the hypotenuse of the two right triangles. And then we also have CF equal to BE, which is given to us. Therefore, we'll conclude the two triangles are congruent. Triangle BCF is congruent to triangle BCF is congruent to triangle CBE. RHS Congruence Rule. Now look at this second triangle. I did not name this BCE. Instead, I called it CBE. Because when you write the congruency of triangles, first triangle you can write randomly. We have discussed it earlier. First triangle we can write randomly. For second triangle, you have to choose corresponding point in the corresponding place. Corresponding point of B in the first triangle is not B in the second triangle also. You can see the angle at B and angle at B. These are not equal. Moreover, B is the included angle of side BF and BC. Here B is the included angle of the side BE and BC. We have already BC equal to BC, but BE is not equal to BF. BE we know is equal to CF. Had this BE been equal to BF, then B also would have been the corresponding point of B. But B is not the corresponding point of B here because BE is not equal to BF, the arm. Instead, BE is equal to CF, which therefore shifts this corresponding point here B to C point here. Corresponding point of B is C, so I in place of B wrote C. Similarly, corresponding point of C is B and that of E is F. F is a vertex containing right angle, here it is E, so the corresponding point of F is E. These two triangles therefore are congruent. Therefore, from this congruency, what shall we conclude? According to CPCT, their corresponding angles now will be equal. Angle at vertex B will be equal to here angle at vertex C. Now when you name this angle B here, had these been the diagrams, we would call this angle B short name, this angle C short name. But in the actual figure at that vertex B, many angles are formed. Therefore, better is give the full name to make things more clear. Now identify angle, full name of angle B in that figure. It is the angle which has one arm BC, another arm BF. That BF extended to A. Therefore, the name of the angle will be ABC. Therefore, angle ABC is equal to. This angle is equal to the corresponding angle C there. And similarly, you have to now name that corresponding side. Full angle will again give, full name of that angle will give. Because at C also many angles are formed in the actual figure. So we'll give the full name. And to identify the full name, we have the arm BC, this is the arm, and arm CE, which is extended to A again. Thus, the name of the angle will be BCA is equal to angle BCA. CPCT. We have to prove that the triangle ABC triangle is isosceles here. We have to prove that triangle ABC is isosceles. Now, isosceles triangle means which has two sides of equal length. That result we'll get by using this result. We'll now consider the original triangle. So right now, in triangle ABC, we have two angles equal. Angle ABC is equal to angle BCA. We have proved it. And then use the result, equal angles of a triangle have equal sides opposite to them. Side opposite to angle ABC is AC in that figure. Therefore, AC is equal to side opposite triangle BCA. Side opposite triangle BCA in that figure is AB side. So we have AC equal to AB. Means two sides of this triangle are equal. Therefore, we conclude that it is an isosceles triangle. That completes the proof of this question. Finally, the last question, question number 5 of this exercise. Let us complete this question also. This is a smaller one. Statement is ABC is an isosceles triangle. It is given to us that ABC is an isosceles triangle. Two sides are equal. ABC is a triangle. It has two equal sides, AB and AC, as per the statement. Draw AP perpendicular to BC. Perpendicular is drawn from A to BC. And the name of the perpendicular is AP. We have to show that angle B is equal to angle C. This angle we have to show is equal to this angle. This is a simple question. Well, as usual, write given and to prove from the statement. First write given. Start from the start of the question up to perpendicular BC. Draw AP perpendicular to BC. Up to that you have given. And then what we have to show, that you will write in to prove. Angle B is equal to angle C we have to prove. Let us write the proof. To prove this, we have two triangles involved in this figure. Smaller triangle ABP, ACP will prove this congruent. You can easily prove now. In triangle ABP and triangle ACP, we have. Prove them congruent. This time also, like previous question, you have to use Rhs congruency rule. You have right angle in both the triangles. Angle at P in this triangle is 90. This triangle also it is 90. Then AB we know equal to AC. This is the hypotenuse of this right triangle as well as this right triangle. AB is the hypotenuse of this right triangle. AC is the hypotenuse of this triangle. And we know these are equal. Then there is common side AP. Rhs rule. Angle APB is equal to angle APC. Each 90 degrees. AB is equal to AC. This is given to us. Common side AP. Therefore, triangle ABP is congruent to triangle ACP, Rhs congruency rule, and then CPCT will give us angle B equal to angle C. That completes the proof of this question. With that, we conclude the day. All the best.